Hello, welcome back to our series on matrices. In the first part, we learned about how to identify a matrix and how to identify individual elements in matrix. The second part, we learned about equality of matrices. In the third part, now we will learn about the different types of matrices. Knowing the different types of matrices will help us in identifying what can be done and cannot be done in different matrix types. So the first matrix type that we're going to learn about is row matrix. A row matrix, as the name suggests, has only a single row of elements in its matrix. So a row matrix will have only one row and can have as many columns as possible. So in this given example, you have a single row and 4 columns. Since we have a row matrix, its counterpart, a column matrix, also exists, where you have a single column but multiple rows. In this case, we have 4 rows but 1 column. So anything that has a single column is called a column matrix. Then we have the zero or null matrix, where every element in the matrix is a 0. So as you can see, this is a null matrix with all elements being 0. Typically, this will result when we do any mathematical operation, and the order of a null matrix can be anything, though we have seen a 2 cross 2 matrix here. Then comes a square matrix. Here I am showing you two different types of square matrix. There is one which is a 1 cross 1, which is a single element. A square element matrix is defined as a matrix where the rows and columns are equal. The number of rows and number of columns are equal. So a 1 cross 1 is also a square matrix. So is a 2 cross 2 matrix. So is a 3 cross 3. So is an m cross m matrix. Right? So the key to remember is a singleton matrix is also a square matrix. Then we have a new type called a diagonal matrix. A diagonal matrix has only elements, non-zero elements in the diagonals. If you look at the given matrix here, only the diagonal, which is A11, A22, A33 are non-zero, whereas all the other elements, which is where the row and column are not equal, are all 0. Such a matrix is called a diagonal matrix. A special case of a diagonal matrix is an identity matrix, where this is a diagonal matrix, which means only the diagonal elements are non-zero and everything else is 0, but the diagonal elements themselves are equal to 1. Such a matrix is called an identity matrix, and identity matrix are typically denoted by the capital letter I. Capital letter I is generally reserved for identity matrix, so avoid using them when you're solving problems to denote any matrix that is given, because I is a special letter reserved for identity matrix. It avoids confusions. To summarize, we learned 6 different types of matrices. 1. Row matrix, only one single row and multiple columns, and column matrix where there is one column and multiple rows. 0 or null matrix where every element in the matrix is 0. Square matrix where the number of rows and number of columns are equal. Diagonal matrix, which is a special case of square matrix where all the elements other than the ones on the diagonal are 0. The ones on the diagonal have value. This is called a diagonal matrix. And a special case of diagonal matrix is an identity matrix where all the diagonal elements are 1 and the rest of them are 0. That covers most of the commonly occurring types of matrices. In the next series, we shall learn about addition and subtraction of matrices. Keep watching MathSmart and subscribe to MathSmart. Thank you.